In this video, we will compare the Maclaurin series and the Taylor series centered at 0 to 6. So data validation, list of items, the center will be 0 to 6. In this case, we'll use the cosine function. So this is equal to RA formula, cosine of the x values. The Maclaurin series for cosine is the summation of a times x to the power 2n, where n is from 0 to infinity. 17 is good enough. And the value of a, the coefficient a, which is the expansion coefficient, is equal to RA formula minus 1 raised to the power n. Divided by factorial, this is 2n, so 2 times n. Now we can complete the Maclaurin series expansion of cosine. So RA formula, series sum of the x values raised to the power 2n, where 2n starts from at n equals 0 to 0, so 0. Followed by 2n plus at n equals 1 is 2 times 1, 2, then 4, then 6, so the interval is 2. And the coefficient a will be this range. Next, we continue with the Taylor series, which is the summation of b times x to the x minus theta raised to the power n, where the value of b is RA formula, cosine 0.5 times pi times n plus the center theta, divided by factorial of n. You will notice the expansion coefficient of the Maclaurin has no interval compared to the Taylor series. Now we can complete the Taylor series expansion. So RA formula, series sum of the x values raised to the power of x minus theta. So x minus theta, where theta equals 0, that means this is the Maclaurin series, where n starts from 0, incremented by 1, and the coefficient will be this range. So here's the Taylor series, and they're the same because it is centered at theta equals 0. And we'll chart this. Insert chart, and we use scatter chart. Use column A as label. We don't need the title, so we'll delete this, but we show the trend line. So we go to series, show the trend line, the type polynomial, the degree 6. For the label, use the equation, and for the legend, position at the bottom. Here's a trend line of the cosine polynomial and the Maclaurin series and Taylor series of the cosine. Next, we calculate the polynomial regression coefficient using Linus. To do that, we complete the Linus matrix. So this will be x to the 0, so start transpose. This will be transpose 0 to 6. And the elements of the matrix, RA formula of the x values raised to the power 0 to 6. Now we use Linus to calculate the polynomial regression coefficient, starting with cosine. Theta y and data X. Next, the Maclaurin series, linest, data Y, and data X. And finally, the Taylor series, linest, data Y, and data X. Then enter. Now let's compare the polynomial regression coefficient with the chart. Coefficient of x to the 0, 1. Coefficient of x minus 0.0555. This is minus 0.0573. There's an error in Taylor series. Coefficient of x to the x squared, which is negative 0.354, negative 0.35. Coefficient of x cubed, negative 0.147, negative 0.151. Coefficient of x to the fourth is 0.117, 0.118. Coefficient of x to the fifth, minus 0.0201, minus 0.0203. Coefficient of x to the sixth, 1.07 times 10 to the minus 3, 1.8 times 10 to the minus 3. Suppose we center our Taylor series to 1. You still get the same values, but this time the error's gone. And their polynomial regression coefficients and their datasets are the same. Center theta at 2. So Taylor series centered at 2. We still get the same values. They're still the same. And their datasets are the same. Center at 3. There's no change on the polynomial regression coefficients. No change in the polynomial. The trend line, they're still collinear. The dataset, they're still the same. Center at 4. We still get the same values. And their values here are still the same. Center at 5. There's still no change. They're the same. So no matter what the center, Taylor series and Maclaurin series are the same. So center at 6. There's a slight error now. But they're still collinear. And the polynomials, there's an error on the last term. There's a slight error on the same. They're all the same. So this completes the use of series sum function, linest polynomial regression, cosine in the Taylor series and Maclaurin, comparing Taylor series and Maclaurin series of cosine function in Google Sheets.